Hi again, everyone. So a couple of questions have come in through email, so I thought I would just do a quick recording. And the first one had to do with finding the number of terms. So sorry, let me just separate here like this. Okay, so this is our first question right now. How do I determine the number of terms for this question if you're given the sequence 4, 12, 36, and then a final term of 8,748? And then here we have an annuity question, which actually has a bit of a problem with it. The question doesn't seem complete. But anyway, we're first off going to do this first one. So we're given the the sequence 4, 12, 36. And then we know that the last term is 8,748, or at least the last term we were given. So as with any sequence, you want to first off, and what we're looking for is what value of t is this, right? So first off, with any sequence, you want to see if it's arithmetic or geometric. Looking at this, we clearly can see it's not arithmetic. We don't have a common difference, but we do have, if we check 12 divided by 3, or sorry, 12 divided by 4, we get 3, so we can see this was multiplied by 3. 36 divided by 12 is also 3. Okay, so this is enough to tell us that our common ratio is 3, and that tells us it's a geometric sequence. And so we also know that A, the first term in our sequence, because we were given our sequence, is 4. Okay, so you should first off write down the general form, the general equation for a geometric sequence. Tn equals ar to the power of n minus 1. And we did an example of this in one of the virtual classrooms, so there's already an example of this when you end up having to solve for an exponent. But you also have to know where to place these values. So we want to know what value of n this number represents. So in other words, what is Tn? Well, if the value of Tn is 8,748, what I want to solve for is n. What is n? Okay, so you're just substituting in. A is 4. R is 3. The exponent remains as n minus 1. Okay. Simplest thing to do at this point is to see if it would let me change colors, but it won't. The simplest thing to do at this point is to just simplify your right-hand side by dividing both sides by 4. Okay, it's going to get rid of things a little bit for us. We end up with 2,187 on the left-hand side, and 4 divided by 4 is 1, so we're left with 3 to the power of n minus 1. Okay, now you are not using logs, and so the way to solve for this is if you can have, if you can express this value, 2,187, as an exponent with base 3. Okay, so 3 to the power of what equals 2,187. And you can sort of, some numbers you'll see, you'll know them. Otherwise, you can play around with looking at the taking roots, and this ends up being that the 7th root of 2,187 equals 3. Well, if you don't know that, how are you going to determine that? Well, given that, and here's the trick, okay, and this came up in our other lesson as well, given that we want things to be a base of 3, can we just take 2,187 and continuously divide by 3 until we get, until we actually reduce it right down to 3 is one way of doing this. Okay, so a lot of people like this. If we keep dividing by 3, you're going to get 243 in your next one. Okay, for me, This is a little long, but it does work. Here we would get 81, and at this point you might be able to go, oh, okay, now I know what this is, right? But you have to kind of keep track of this. We've divided by 3 once, twice, 3 times, and you're going to continue doing this, okay, over and over, and you're going to end up doing it 7 times. And I'll let you play around with that and do that. So the point here is that 3 to the power of 7 equals 2,187. Okay? Now, if we want to continue, knowing now that 3, sorry, this I lost. Sometimes this happens, particularly when working. So this is actually, should say 3 to the power of 7, and you can just evaluate that on your calculator. 3 to the power of 7 equals 2,187. So if I rewrite that now for the full equation that I had, 3 to the power of 7 equals, so this is just on its own, that these evaluate this, the value of this. But my equation, if you remember, and we go back up a little bit, here's my equation that I started with. 2,187 equals 3 to the power of n minus 1 from my geometric sequence formula. So 3 to the power of n minus 1. What are we trying to solve? We're trying to solve for n. Right? So now that we have expressed both of these numbers with the same base, they have a base of 3, we can equate the exponents. Okay, so let me repeat, you can only equate exponents when they have the same base. All right, which is why we had to go through all of that. So now I can simply say that 7 equals n minus 1. Now we're just going to rearrange and solve this equation for n, which means I'll bring 1 to the other side. So I have 7 plus 1 equals n, n equals 8. So from my original question, Tn equals 8,748. Okay. Or sorry, I said Tn. T8 equals 8,748, and I think I've got that number correct. Okay, based on time, I'm going to stop this recording and I'll come back for the other question and I'll put it in as a separate recording.